for this semester, this year. So, yes, thanks to the author and your close friends that have showed up here. Let's see. For this session, we were supposed to have 5 papers, but the second author had to cancel due to some sort of conflict. He was unable to attend. But for this presentation, we have about 15 minutes per paper, and then a few minutes for Q&A after that. And I'll hold up a 2-minute sign when you're about 13 or so minutes in. The first paper is an artificially intelligent method for STEM-based electrical engineering education and pedagogy case study for microelectronics. The author is Dr. Faisal Safia. Is that correct?
Faisal Safia, correct. Yeah.
From University of Waterloo, Canada.
Thank you very much. Good afternoon, everybody. So, welcome to this talk. So, this afternoon, in this session, I will talk basically about an inspired method from artificial intelligence and the embodiment of that method into the teaching and indication of STEM-based electrical engineering course, namely microelectronics. Okay, this course I have taught it actually mainly in UAE University, but I'm developing this quite fast. We'll talk about that in a second. So the outline of this talk is basically divided into 8 bullets. First, I'll talk just briefly about myself, not to brag about who am I, but to show you the reason behind this method basically. And then I'll ask the most important question, which is what's intelligence? Okay, we'll see many definitions, and from there we'll try to basically see how we can harness this power. Okay, I developed also a formula for that, but not in this talk. I developed it earlier for imaging. But I will just pass that. I'll talk only about how to harness it for the education purpose. Then from there I jump into from harnessing into basically the application of the intelligence engineering in teaching. Okay. Then define what we mean by smart teaching basically. What do we mean by smart teaching and why it's necessary? And then from there we get to the approach, the exact approach, which is divided into 2. One is the multidisciplinary approach using the Hebbian rule in neural networks. If you know that, I will explain that very briefly. And then the second approach, the multi-channel approach, or what is commonly known as blended learning. Okay, and for that I will also use the artificial neural networks, but in the associative memory aspect. Okay. Then finally, of course, we have to assess this method using the student response, and I finish with this. With a simple conclusion. Okay, who am I? My name is, again, Faisal Safi. Okay, I did my bachelor in solid state physics with best honors in Algeria back in 1996. Then I moved into to Malaysia where I did my master's in also biophysics in digital implementation of neural networks back in 1998. Then from there I moved to Canada, okay, to develop smart CMOS image sensors. Using biomimicry of the retina and the biological vision at the University of Waterloo back into like how many years? 12 years ago. Alright? And my research area is basically on intelligence design in devices, circuits, and systems. And again, I'm not talking about intelligent, I'm talking about intelligence. Intelligence being the power or the aspect I'd like to implement. Okay? So I'm not bragging about myself, I'm bragging about biological intelligence. Career span, basically I touch 3 levels: academia, industry, entrepreneurship, and all of that can be checked out in my LinkedIn. So I am a guy, a humble guy who likes intelligence and love it, and got inspired by it. But what is really intelligence? The Greeks, and even before the Greeks, they asked about this intelligence. And one funny but really interesting definition by Socrates, okay, he basically quote or said something that's really funny, but very, very inspiring. He said, I know that I'm intelligent because I know that I know nothing. It's really funny, but it's really very mind-blowing. Why? Because he expressed the first aspect of intelligence, and that is the self-awareness. And that's what the current AI actually, the big boys who are working on AI, Apple, Microsoft, and the other guys, they're trying to make, okay, if the AI get to the level of self-aware, bye-bye. That's another story of mankind, okay? They will take over to some extent, okay? So self-awareness is the very strong backbone of intelligence, and that's very, very important for learning. I'll explain that in a second. Then other definitions, here I pick only what is really, I see it like a pillar in intelligence. The second definition is by Albert Einstein. He said, the true sign of intelligence is not knowledge, but is imagination. In fact, he described the education as not the learning of facts, it's actually the training of the brain to know or to think. And that's, I call that in all my videos that I use for education. And basically what he's trying to describe here is the creativity aspect of the intelligence. And that's very, very important for making and designing. And that's basically what engineers are meant to do, okay? And the third aspect, which is very also important, is the different axes or different dimensions of intelligence. You can find intelligence as analytical, linguistic, emotional, etc., etc. There are many, many dimensions and axes of, intelligence. And psychologists and neuroscientists, they actually not in agreement at all about what really makes the intelligence. So still, the bottom line is that there is no consensus of what is really intelligence. What we are seeing is that the reflections of intelligence. We don't know what's exactly, but it's something that we can see its reflection here and there. Okay, good. So Einstein also mentioned after many, many years, he said actually after 30 years of working on photons, and he got the Nobel Prize for the photoelectric effect, for those who are aware about that, he said after 30 years we don't know what's a really photon. And yet we use it, and you can see around you. Okay, so it doesn't stop the mankind to use things that in fact we don't know. So what we don't know, let's harness it, let's use it. And how do you harness it? There are actually two aspects: the heuristic non-algorithmic processing, which is known as the artificial neural network. It's been used everywhere. Okay, this is one aspect of that. So, and how do we do that? Basically by mimicking the neurons and how they are interconnected to do some processing. So that's the first aspect. The second aspect is in your pocket, is in your smartphones, by integrating the functionalities, okay? So the phone integrate functionalities, faculties actually. It can measure things, can entertain you, etc., etc. The integration of functionalities or faculties, sensing, control, signal processing, etc., this makes the device smart. Why? Because the brain does that. The brain sense and control and imagine and process and all these things. So the integration of faculties and functionalities makes the thing smart, and that's why we have an I before the phone. iPhone is an intelligent phone. So that's another aspect of the engineering, the intelligence engineering that we have nowadays. Okay? All right, good. So this is what we have in real life, or in terms of what is really meant by intelligence. Okay, good. So how can we use that in teaching and education? And in that sense, I defined the smart teaching, okay? Or it's well defined, but it's something that inspired me. Can we make teaching really intelligent? Why? Because we need it, okay? And for that matter, I ask myself these questions. What do we really mean by education and teaching? What's the objective? What do we want from that? Really? Are we looking to check with our assessment in education the memory effect of the students' brain? Are we checking whether they recall very well or not? Or are we checking their skills? But if we do that, how can we do that? How can we double check or make sure that they have the skills, that we are checking for skills, that they learn the skills and we can check the skills, not wasting our time to do memorization. Memorization doesn't teach. Again, Albert Einstein, I'm quoting him and I still endorse that. The education is not about learning facts. Things change. But it's actually about teaching the students how to think, how to solve, okay, and how to design, how to be creative. Now, the last question, and in here, which also is of great importance, are we teaching in the mode of master-slave? I mean, one-directional teaching, or are we teaching in a way that is self-driving, that the student learn? Put the seed in the students and let them learn and move forward instead of waiting the teacher to tell them what to do. Okay? So the teacher, is it supposed to be an advisor, a guider, or it just has to be a master to feed the student or give them the fish through the Chinese, proverb? Okay, good. So this is a necessity. We need really to implement intelligence in teaching. How we do that? That's a very interesting question to answer. So, what is smart teaching or learning? I define smart teaching and learning by the dynamic process of grasping the knowledge. So dynamic, that means it's not one flow, it's not one direction. It goes both ways, okay? From the teacher or educator to the students and backwards, okay? For any discipline, okay? So I don't believe that is a master-slave approach. It's actually a very dynamic approach, and they will see why in a second. And also the smart teaching is the area whereby the student factor is central. So the students are really central in this approach in the sense that they dictate the way how do we teach. It's not the teacher dictates that. So that's the other aspect of smart teaching. And of course, because of this, the psychology of the student is of a pivotal importance in developing the teaching in the sense of blended learning, experiential learning, or learning by example, etc., etc. All these examples, they factorize the psychology of student to allow the student to learn in a very effective way. Okay. The second one is to approach the teaching in different ways, not only one way. Now we have the digital way. Why not blended learning? Okay. Or the other modality like flipped classrooms and stuff like that. We should not come only on one way. We have many ways. Let's use them. And also this, I will explain that in a second. And all along in the smart learning, self-awareness has to be embedded in one way or another. Student must know whether he or she knows or not in a creative way. All right, good. The first thing that I did in this course of microelectronics is that I tried to bring the lab to the students because time constraints and all these things, and I have tried to embed STEM into the course. By how? By basically embed the discussion. These are two snapshots of videos of the same course, actually, the same class. One, I'm discussing the mathematical aspect of a certain physical parameter that is important in the diodes, which is the barrier voltage, and how it changes with temperature. You are actually invited to go to this link to have a look at this, to see how we discuss it in a nice intuitive way, how this function of barrier voltage does change with temperature. So once we talked about it to the students, some of them they understood, some of them not, that's fine. But to enhance the understanding of that, I have to bring something more convincing, something that is a lab. So basically I took a diode and went to the lab, blow it with a heat blower, and show them the barrier voltage decreasing with temperature. So this is a convincing aspect. But why do I do that? It's just because the Hebbian rule, which is the rule that is used in artificial neural networks to teach the synaptic strength, which are between the neurons, that helps the recall process. And that says basically that actually Donald Hebb is a Canadian psychiatrist who worked by the end of 1940s, early 1950s. He found that some excitation of neurons actually excite other neurons. And the way that he basically explained that, he said that the synaptic strength between them, it allows that dynamics. And so basically, in order to embed or teach the student a certain aspect, we should bring them more than one way of teaching that aspect, or more in another way, more than one way to convince them about the reality of the thing. So that's the thing. That's what I meant by using the Hebbian associative learning. So these two aspects of learning, once the lab, once the theory, bring them together, we can enhance their knowledge in that sense. So basically the STEM in this case is embedded by interacting the different aspects of the STEM curriculum. Basically in this case, I'm bringing science or math okay, and technology if you want, okay, because I'm not designing anything. So math and technology in this case, they are basically interacting together on the same aspect in a way to mimic the Hebbian learning rule of the neural networks to basically enhance the learning of the students, okay? So that's the first approach that I did, and I called it multidisciplinary, because I'm bringing two disciplines in here, engineering or technology and math, under the STEM umbrella, to teach them a concept, in this case the voltage, barrier voltage here, and how it behaves with temperature. The second approach, okay, which is also very interesting, is by bringing the associative memory aspect of how the biological memories work. They work by association. And in this case, so I'm bringing the multi-channel approach to the table. So basically this is my class, okay? So I try to embed STEM as much as I can, the way that I just discussed it. So this is done. So now that aspect, okay, is being taught in class, and that is recorded by camera. So basically I record every single class, and the student later on of class, in the recording process, the student will watch this recorded movie of the class, and basically will be able to basically remember the concept that has been taught in the class. So basically I'm associating basically the video information here, which is this layer of neurons, with the concept that is being learned, okay, which is the memory that is inside the brains of the students. So this dynamic in between the video and the memory of the students, this dynamic helps a lot in recalling the concept and strengthening the concept that students have. Okay, good, almost done. All right, so this is second approach, and that's the last one actually. So basically we are done. Then I made the surveys, okay, about what are the different tools that students they use in their revision. So I divided that between the textbook, the PDF slides, and the YouTube channel, or the course, the digital version of the course on YouTube. And what I found interestingly, you can see that the students, and I did that for both pre-midterm and pre-final, okay? So I found that the students, most of the time they start with the PDF slides, which are very dense in terms of information, then they go to the textbook, and then they go to the YouTube. But it's very important, as you can see, most of the time it's green, and that's what I'm discussing in here. And this for both pre-midterm and pre-final, okay? So why they do that? So basically to minimize the energy that the student need to spend in memorization, okay? And finally, here in the feedback, they at the end of the course, the students basically they mentioned what they think about this approach, and they think that this was very interesting, okay, more fun, okay, and basically the only class they don't feel sleepy, because they started early in the morning, okay, so that's a testimonial from them. In conclusion, I think that the biological intelligence, the biological intelligence systems are inspirational to improve the engineering education. The student psychology is of a great importance, if not the most important factor in this regard, and basically that the intelligence as a natural power embedded in biology should be used in education in the following aspects: by enhancing the self-awareness aspect of the students, by interconnecting various ways to enhance the convincing aspect of learning, basically using STEM in this case, by using different approach to teach a concept, and finally by blending the various teaching modalities, like here digital, YouTube for example, and the in-class interaction. And that's it. Thank you very much for your attention. If there's any question, I welcome on.
We would have time for about one question.
Just one?
Oops. We can talk after the session, that's fine.
So
Go ahead.
I have one question, okay.
Sure.
So you've got your YouTube of every lecture, right?
Yes.
So by chance, do you have an index, a time index the index of what topics you're talking about on that YouTube?
That's a very good question actually. Some classes I did that when I found the notion is very important. Like for example, for the when the barrier voltage does change, I discuss it mathematically and experimentally. But that's also in the list, so that's my plan. So the next step to the videos is to index the different sections that I'm talking about in the video, and the student just click on the time and it goes right away there. But thanks, that's a very good question. Yeah. Is there any other question? Still we have time, I think they are preparing.
So,
Go ahead.
I would agree that in graduate school, students need to be very intelligent and all, but I don't think we can totally do away with the master-slave model in elementary school or vocational school.
But
And like in vocational school, students pay money to say, I want to learn this thing right here, and I want to receive that information, and there may not be much intelligence there.
And that's why it's not a very good way of teaching. The best way of teaching must be in an interactive way, that not in a master slave. Otherwise, the knowledge does not accept that. That's the nature of knowledge. It has to be dynamic way of learning.
All right, I'm not convinced right now, but.
We'll talk about that after the session. Thank you very much.
Thanks.
Thank you.
Okay. Thank you.